Welcome back. One of the first things that we're going to do is I'm going to show you a 5-minute video on what scale models and scale drawings are. Just a few examples so you have an idea in the back of your mind. And then from there, just go through some other examples with you. I'm going to show you some pictures of my own in reference to scale models and scale drawings. And then we're going to head into the book and look at some examples as well. So I'm going to play this right now here through this video. Let's take a peek.
Today we are going to be talking about scale models and scale drawings. A model is a copy or representation of an object. It could be smaller than the original object or larger than the original object. In the example you're looking at right now, we have a model of the city of Chicago, and then we have the actual city of Chicago that we're comparing it to. When you look at the orientation of this picture, you see the water is on the right side over here. But in this picture, the water is over here on the left. So this section, this strip right here, is actually this strip back here in this photo. And I say that just so you can kind of see that we're looking at it from a different angle. And I wanted to compare this building to the original building, and this pointed top building to the actual real life building. And I want to talk about the fact that when we say scale model, we're saying that this model is proportional to the actual city. So what I'm saying is that the ratio, if you look at the ratio of the height of this pointed building to the height of this pointed building, it would be the same as the ratio of this tall building to this actual building in Chicago. So the ratio is the same. It is to scale. So it's basically like you're taking an object and you're shrinking it or you're growing it. In this case, we shrunk the city of Chicago and made a model out of it. Let's look at the next example. This is a model airplane. Take a look at this airplane. And then here's the actual airplane. So the model is proportional to the actual airplane. All right, this is a scale model. This picture was taken from the show called The Apprentice. And this is the Trump National Golf Club in Los Angeles. This is a model. And then this is the actual golf course. So you can have a model of a golf course. You can have a model of a building. You could have a model of a vehicle. And there's always, when you look at a scale model, there is a ratio or a scale. So this limousine is 1/38 the size of the actual stretch limousine. Or you could say, you could compare it like this. 1 centimeter in this limousine would be equal to 38 centimeters in the actual limousine. So it's just telling you basically how much smaller this model is than the actual stretch limousine. All right, here's some tractors. This is a model. It's the largest model that we have. So these are not the real thing. These are just models. And this model is a 16th of the actual tractor. And this tiny little model is a 64th of the actual real life tractor. Let's move on to scale drawings. So this is a blueprint of the Yankee Stadium, and then here's the actual stadium. Here's an example of some house plans. So these plans would be drawn to scale, and then a builder could use them to actually build the home. So here's another example. Here's the scale drawing, the plans, and then this is the actual building. And this is used, this small drawing, to create the actual building. All right, this is a blueprint of the Eiffel Tower, and then there's the Eiffel Tower. I like this drawing of the Eiffel Tower, this scale drawing, because it shows the scale. 1 centimeter on this drawing is equivalent to 36 meters in real life. And then one more example. In this drawing over here, 1 centimeter in this drawing represents 5 centimeters in the real life sculpture of this hand. So when you have a drawing or you have a model, there's always a scale or a ratio to show you how to scale up. A lot of times we use scale drawings or scale models to picture what the real thing will be like and to help us to build the actual real life house or sculpture or whatever we're working on. So I hope that you got a good little intro to scale models and scale drawings, and you'll know what I'm talking about when we work on the math problems today.
Okay, so let me get out of here. And I'm going to take you to a couple more pictures. So this was years ago. Let me make this a little bit larger. We had gone to Florida, and when the kids were little, we went to Legoland. So I don't know if any of you have gone to the Legoland in Florida or anywhere else, but if you do, they have this little miniature park of different areas in the US or actually overseas as well, of the most popular attractions that are scaled down and built with Legos. And so in this picture that you're seeing right here on the right, this was Kennedy Space Center. And so this is the scaled down version of the original. And again, it's all built with Legos. Now it looks really big within the picture that I'm showing you here, but honestly, it's very small. It's a very, very scaled down version of the original. In the upper left-hand corner, this is a scaled down model of Daytona International Speedway as well. It looks a little real. Like you see all the fans in the stands over there. Those are just Lego people. This is what like the infield of a race would look like, and then that track going around it. But again, it's the scaled down version of it. This is in Las Vegas, so scaled down version of going along one of the strips down Las Vegas. In Las Vegas, of some of the buildings that are there, some of the casinos that are there. So this is also, Washington, D.C., and so you can see like the people walking around, all the visitors going through this little miniature scaled down park. It's hard to tell. It almost looks like the people are the same height as this picture that I have zoomed in, but they're not. Again, these are very, very small when you go to visit scaled down versions. Statue of Liberty, and then an area in San Francisco. So very cool to see. It's just interesting to see how scaled down that they can make them, and the replication of them looks like the real thing. So again, that was a couple years ago. They still have Legoland in various parts of the U.S., and it's a pretty neat experience to go through and walk through that. So we're going to do a couple things. Let me go back here. There we go. I want to look in the book with you on page 576. And in the book, we're going to take a look today specifically with maps and a couple other models, just to understand how these problems get set up and how we work through them. So this is where you're going to go to page 576 in your book, which is going to look like this. And we're going to talk about maps to start with. So if you haven't gotten your book out yet, make sure you do go to page 576. This is what we're going to start with, is example 1. So if you have to pause the video and get that out in front of you, please do so. All right, so I'm going to show you an example of a map of Detroit really quick before we get into example 1 on page 576. So this right here is a very old school map. In fact, I'm not even sure. I haven't even checked to see if really how many of these are actually made for people anymore. I know people still use them, but they're not as widely used anymore as Google Maps, right? So growing up, when we would go on family vacations, this is what my parents would use. They'd pull out a map of wherever we were going. So if we were traveling from Michigan to, let's say, Alabama for spring break, they had a map for every state, and they would map out the distance, how far it would be in miles, how many hours it would take us to get there. So, Google Maps does that for you now, and you don't have to worry about that. But at the same time, some will still use these if they're traveling, let's say, within a city. So, let's say you're visiting Detroit for the first time and you want just a general overlook of what that city looks like. And so, on the right hand side here, this is a paper map of the city of Detroit. And you'll see, right, there's actually a key here, and it's hard to tell, but along the left side here and along the bottom, it's labeled with letters and numbers, and it helps you pinpoint where certain parts are in the city of Detroit. You used to have to use this key to help you find different parts of that city. Now, also in the bottom left hand corner is a legend. And so this is a little bit more zoomed in here. And legends show you all kinds of different things. You can see it right now. It tells you where the interstates are. It tells you where tunnels are, if there's any toll roads, ramps, rest areas, any other symbols you may need, airports, hospitals, and so on. This is, again, a legend for you to use. Now, there's also what's called a scale. So at the very bottom here, it says 1 inch equals approximately 2.5 miles or 4.02 kilometers. And so it gives you an idea, like if you were to go to this map and measure out however many inches you need to go from one part of the city to the other, it's telling you every inch you measure out, it actually represents 2.5 miles traveled in your car. And so, again, this is very old school. It's very rarely used, but I wanted you to see that because some of the maps that we're going to take a look in the book is going to show you the same thing. It's going to have a scale. It's going to tell you however many inches or centimeters it is on the map, and then how many miles it's going to represent actually traveled. Okay, so we're going to head to the book, and we're going to take a look at this first map in example 1. Now, this map is not detailed by any means. It's just giving you kind of an overview of two cities that you're going to look at and find out how many miles it is to travel between the two in Maryland. So it says, what is the actual distance between Hagerstown and Annapolis? Now, step 1, it says use a centimeter ruler to find the map distance between the two cities. So this year, of course, with the way things are set up, I don't have rulers to pass out to you. It just wasn't going to work out that way in the lesson. So what I'm going to do is just basically tell you if I take a ruler and I measure on the map between the two cities, how many centimeters it's going to be, or whatever we're using. Okay. I'm just going to tell you what it would be. The more important piece is understanding how you use it mathematically, how you set the proportion up to find out how many miles you're going to travel actual. So it already, since this is the example, the book example, it says the map distance is about 4 centimeters. So what happens is you write and solve a proportion using the scale. So you'll see here in the bottom left-hand corner, I'm going to circle it. Here's the scale for that map of Maryland. And it says every centimeter that you measure with the ruler in between Hagerstown and Annapolis is going to represent 24 miles actual driven distance. So when we did proportions in chapter 1, way back at the beginning of the year, when we would set up proportions and when we had stories, we talked about how important it was to make sure you had labels with those stories. And so same thing here. You're going to notice, here's the scale, 1 centimeter. So I'm going to draw a line, or an arrow, excuse me, right there. 1 centimeter is 24 miles. On the map, every centimeter traveled is an actual 24 miles traveled in your car. So if you set that first fraction up in your proportion, and then I tell you that with the ruler, if you take the ruler in centimeters and measure between Hagerstown and Annapolis, it's 4 centimeters. So notice in the second fraction in the proportion that it says 4 centimeters. So your labels match in the numerator. Those are your map measurements in that numerator there. Now this says D miles, distance. How many actual miles is it going to be? This is what we're solving for. This is the actual amount down here. So when we solve proportions, we did some cross multiplying, and that's exactly what's happening here. So you'll see 1 times D, 1D, 24 times 4, it's 96. And so it's 96 miles actual distance in your car traveled. All right. So let's try one. So again, you're going to have to trust me here that I'm going to tell you when I use a ruler, I'm going to tell you how many centimeters, is it centimeters this time? Yep, how many centimeters it is between these two cities. So it says, on a map of Arkansas shown, find the actual distance between Clarksville and Little Rock. So here's the scale right here. And I'm going to set this problem up just like example number 1. So we're going to take and draw a proportion off to the side here. And the first thing that you're going to do is put in that scale. So every centimeter, 1 centimeter, is going to represent 20 miles traveled. And so this is the map, right? 1 centimeter, every centimeter. The 20 miles is the actual. And now, if you use a ruler to measure in between these two cities, between Clarksville and Little Rock, I'm going to tell you, I used my ruler and I used the centimeter side, and I went from this dot to the Little Rock dot there on the map, and it actually measures out to 4 centimeters. So again, that's the map amount, right? Using the map and using the ruler, it's 4 centimeters between those two cities. Centimeters and centimeters match in the numerator. You're trying to find, and I'm just going to call it X, how many miles? X miles. So once again, if we think about how we've used cross multiplication to solve, I know I'm going to do 1 times X here and get 1X. And here I'm going to do 20 times 4, and I'm going to see that it's 80 miles. So I can plan out using a map and measuring in centimeters in between these two cities and understanding that using that scale, there's 4 centimeters distance between those two cities, which then actual traveled in my car, if I'm going to drive in my car to from Clarksville to Little Rock, it's going to be about 80 miles. It's going to take me 80 miles to drive and get there. All right. We're going to scroll, or you're going to actually turn your book page. And I'm just going to do a couple more map examples with you. So we're going to go to page 578, 578, number 1. So you're going to notice here, there's no map. It's not showing you a picture of the map, but it's telling you within the problem your measurements and scale that you need. So it says on a map, the distance from Akron to Cleveland in Ohio measures 2 centimeters on the map. Okay, measures 2 centimeters between those two cities. What is the actual distance if the scale of the map shows 1 centimeter is equal to 30 kilometers? So there's the scale. Every centimeter that you measure out on the map is going to represent 30 kilometers actual distance traveled. Okay, so we're going to start with your scale. 1 centimeter, 30 kilometers. So it's not in miles this time. They have it in kilometers. Equals, right? So again, understanding the 1 centimeter represents the map. The 30 kilometers represents the actual distance. Scale version, actual version, okay? And then it measures 2 centimeters on the map using a ruler. They've already measured it out, 2 centimeters. You need to find out how many actual kilometers that is going to be traveled. Okay. So looking at 1 times x here, 1x equals 30 times 2, 60. So 60 kilometers distance, actual. Again, sometimes you'll see it in kilometers, sometimes miles, either one. You're finding the actual distance between those two cities. All right, let's also look at, do one more, actually 2 more. We're gonna go to page 579, and we're gonna look at the independent practice here. So we're gonna see a map of South Carolina. And the directions say find the actual distance between each pair of locations in South Carolina, use a ruler to measure. Okay, again, you're going to trust me when I tell you I've used the ruler and I've measured between these cities when we do this right now. The first thing that you're going to look for is the scale. So in the bottom right-hand corner here, it says every centimeter traveled on the map is 27 actual miles driven in the car. So we're going to look at going from Columbia to Charleston and Hollywood to Sumter. So number 1, start with your scale. 1 centimeter is 27 miles. Map in the numerator, actual in the denominator, equals the distance between Columbia and Charleston. Okay, these 2 cities right here, when I measured it out using the ruler, using the centimeter side of the ruler, it's 4 centimeters. So if we were in person, as far as like in class together, and I could do this with you, we would use the rulers. We would measure in between so you could see that it was 4 centimeters distance. And we're going to find out how many miles that is. Okay. So cross multiply. 1 times x, 1x. 27 times 4. So I'm just going to come over here and multiply that out. And I get 108. So it's 108 miles going from Columbia to Charleston in my car. You try number 2. So set it up, use the scale. I'm going to tell you from Hollywood to Sumter, it measures out 3 centimeters on the ruler. So you're going to use that to help you find the actual distance to travel between those 2 cities right there. So pause the video, work that one out. I'll meet you back with the answer. Okay, so for number 2, you should have gotten 81 miles actual distance traveled. So the 1 centimeter is 27 miles, right? That's our scale. I told you with the ruler, if you measure between Hollywood and Sumter, that is 3 centimeters between those 2. And so then when you set that proportion up and you use cross multiplication and solve, 81 miles actual distance traveled in your car between those 2 cities. So all the examples I just did with you with the map, you've gone from a small scale down drawing to large actual measurements, right? So you're understanding from a scale on a map how many either miles or kilometers you're actually going to drive in your car in between those cities, depending on whatever state we looked at. And every scale is going to be different in every single city, state, everything you look at, you always have to pay attention to that scale because they will not always be the same. So again, we went from small to large, right? Now, we're going to take a look at a couple more. So we're going to go back and we're going to look at, let's see, number 2. So I'm going to try a couple more with you now that we understand, and this is page 578, sorry, Guided Practice 578. We're going to look at something other than a map. Now that you understand how the scales are, and when we look at scale drawings and scale models, there will always be some scale from small to big or big to small that we'll need to look at and use to help us find what it's asking for. We're going to try something other than a map though, okay? So on page 578, number 2. So this says here, you have an engineer that makes a model of a bridge using a scale of 1 inch that is equal to 3 yards. And so the length of the actual bridge is 50 yards. What's the length of the model? So now what it has us doing here, okay, so here's the scale, 1 inch is 3 yards. So for every inch on the model of that bridge, it's going to represent 3 yards actual built on the bridge. It wants us to find the length of the model. So we're going to go the other way this time. We're going to talk about what we actually have, and we're going to scale it down and look at the smaller. So we're going to go from big to small on the model here. We're still going to use the scale. We're still going to use this 1 inch is 3 yards. Okay, we're going to keep whatever scale they're having us use. We always start with that in our proportion. Okay, so up top here, now I'm not going to write map, but this is the model, right? Every inch on the model is going to represent actual 3 yards. So actual amounts will always go in the denominator. Your models, your drawings, your scale down will go in the numerator. It's actually 50 yards on the length of the bridge. Now notice this time, right? I have the actual. And so we've talked about how your measurements have to match. So in the denominator, yards and yards are matching here. I don't want to put it up top. I don't want to put it in the numerator because it's the actual length of the bridge. The length of the bridge is 50 yards. I need to know on the model, the scaled down version of it, how much in inches that's going to be in length. So it makes a big difference. You have to make sure you understand what you're solving for. And when you set that proportion up with your scale, that your measurements are going to match. So now, right, if I cross multiply and solve, so I'm going to have right here 3 times x equals, and then here 50 times 1, which is 50. Now, I forgot to tell you, you could use a calculator. You can scratch it out if you want on the paper here, but if you have a calculator, you can take that out right now. So if you have to pause to grab it, go ahead. But go ahead and take a minute, divide that out. 50 divided by 3, we're going to find out how many inches it is on the length of the model of the bridge. All right, so if you divide this out, you're going to see a decimal that repeats itself. So it's this 16.6 that keeps repeating over and over. It doesn't terminate. So you can leave it like that actually in inches. Okay, you can just put the bar over the top of the 6 to show that it's repeating. 16.6 inches in the length of that model. I wouldn't round it just because when you're talking about actual, building of the bridge or drawing or constructing the model of the bridge, you need the most accurate measurements possible. If you make a mistake in a measurement, it definitely could cause some major trouble as far as being off on constructing the bridge, right? So you have to be very accurate. And so if you have decimals in these situations that repeat like this, then keep the decimal, okay? So 16.6 inches on the model of that bridge. All right, so again, like we said on number 2, you went from an actual bridge length to now the model. You did one a little different than with the maps, right? We had to find the model this time. We're going to try one more. So we're going to go back to page 579 and we're going to look at a different one. So on 579, number 4, we're going to look at this plane here. Now it says find the length of each model and then find the scale factor. We're going to hold off on finding the scale factor. What we want to focus on is making sure we're comfortable with setting these proportions up and understanding what you're solving for. So on number 4 right here with the airplane, this is the actual. So if you look, the actual length of that airplane is 87 feet. And underneath it, you have the scale. 2 inches is 15 feet. So every 2 inches on the model of that airplane, it's 15 feet actual on that airplane. Okay, so for every 2 inches, it represents 15 feet. So we start with that. We get that 2 inches in over 15 feet. Start with your scale, right? So the 2 inches represents the model. The 15 feet represents the actual. All right, we see in the picture that we're given the actual amount length of the plane. So this is where you concentrate on making sure that your labels match. So you're matching the actuals here in the denominator, so that 87 feet goes at the bottom. You're trying to find how many inches on the model of that airplane. So you go ahead and try to solve this one. Use your calculator, use cross multiplication, solve that proportion. See if you can find out how many inches on the model of that airplane, and I'll meet you back. Okay, so if you used your proportion work correctly and cross multiplied and you solved, you should have a model length on that plane of 11.6 inches. And again, I said with the decimals, leave it, don't round it. You need the most accurate measurement on your models that you can get, right? Don't round unless I tell you differently. All right, so at this point, we're going to stop. I just wanted today to make sure I could show you some map examples and just some other model examples for just to start with today and make sure you're understanding how to set the proportions up and solve. And you're also understanding the difference between what is considered a scale model, a scale drawing, and then the actual version of it. So the video that I showed you at the beginning, the Legoland pictures, things like that, just kind of trying to reference what I can for you to hopefully get you to understand what those mean. Now, at this point, if you still have some time remaining, I keep saying BuzzMath, absolutely go to it if it's not done. The Pi Day graphing activity that I gave you on Friday, you can go back to that. And really, even though Pi Day was yesterday, what's important is you making sure that you're good with graphing on a coordinate plane, especially with the half marks, and using those coordinate points and graphing them accurately. So if you need to go back to what that Pi Day, that pi symbol looks like on the graph that was on Friday's agenda, you could go back and look. And then start working on ALEKS, right? And again, if you have ALEKS that's missing, remember, I need it and Mr. Terpstra and Mr. Whalen need it by Thursday. So use that time wisely at the end of this hour, again, if you still have time. I will see you back here on Tuesday. We'll look at a different kind of scale drawing. We're going to look at a little blueprint of a house and be able to understand how to use a scale from a drawing and what it would actually be within the house when you go to build it. So I will see you back tomorrow. Have a great Monday.